Very good evening, and I extended a warm welcome to all of you for the WI Professional Activities second technical talk uh, of the year 2023 on transforming the traditional software development culture with a well-engineered DevOps infrastructure. So this event is organized by the IEEE WI Affinity Group in collaboration with the IEEE Computer Society Sri Lanka chapter. I'm Prabhani Liyanage, Chair of Professional Activity for the IEEE WI Affinity Group and Women in Computing Chair for the IEEE Computer Society Sri Lanka chapter. So we are delighted to have Mr. Laksuri Balasurya with us today. He's a well-known expert in DevOps, database, microservices, and many more other areas of expertise. So before we begin the session, I would like to give a brief introduction to our resource person. Mr. Laksuri Balasurya, he earned his master degrees in database technology from Staffordshire University in 2016. He currently serves as the head of the capacity planning at Virtusa Private Limited and has over 10 years of experience in various roles, including consultant, end-to-end enterprise solution development as per the client demands, and a mentor in the same organization. He also worked in IBM World Trade Corporation from March 2012 to March 2014 as a DBA team lead, managing the mission critical application plus providing learning solution consultancy for Oracle DB2 apps DBA. So from November 2000 to March 2012, he worked as a lecturer, consultant, and Oracle solution developer at the DMS Software Technology Private Limited. With over 23 years of experience, his primary expertise lies in database, particularly in the Oracle. So additionally, he is an expert in cloud technologies, microservices, containerization, Kubernetes, event-driven architecture, generative AI, especially DevOps, and many other areas in IT and the business domain. So Mr. Balasuri has conducted several workshops in collaboration with the esteemed universities and have been a key speaker at many conferences hosted by the universities. So he brings extensive experience in mentoring and coaching junior professionals to build their competencies. He's a well-versed in conducting seminar, lectures, boot camps for members in both academia and the corporate sector. So without further ado, I would like to invite Mr. Laksuri to share his valuable experience with us. So to you, Laksuri.
Sure. Thank you very much, Prabhani, for that nice introduction. Good evening to your team. Hope I'm clearly audible from here. Yes, I think as the topic clearly introduced by Dr. Prabhani, so it is all about transforming traditional software development culture with well-engineered DevOps infrastructure. So it's like this now. See, there are a few words in that traditional software engineering, because as the word says, it is traditional. It has been intended that there had been right? I mean, there has been certain way that software development took place in industry, right? And now what DevOps, it has done certain transformation to the way that solutions or the development has been taking place in the industry. Now there's been a change, and change now means that's been initiated even nearly more than 10 years back. But now the thing is, in the industry, DevOps has become the one of the top streams, one of the major things, major tech trends. Now, any developer who had been working in this normal development, I would say the traditional way of developing solutions as per the client requirements, now is high time to adopt this new way of developing software, or the developing software as a new culture that is known as DevOps. Right? So let me just share my screen, and let me just share the presentation as well for you. Right? Okay, team, right? So transforming the enterprise software developing culture. And the topic also said well-engineered infrastructure. So let's try to understand these things. So as I mentioned, the traditional software development methodology, because there has been, separate teams were there. Let's say if the requirements are taken from a client, let's say you are required to develop some basic kind of a solution. Let's say the online shopping cart application, I think in last years in the COVID era, a lot of business organization has to switch to online, right? And they had to go for this online shopping because we know what happened. So that was a very big trend. And let's say you have to develop this one. A client or a business organization is demanding for you to develop a solution to enable online shopping for their clients. Now, the first approach, if you take the old approach, the traditional approach, you will definitely get the requirements initially. That's true. This is requirements with clarity. That is very important because client will say many needs. As an organization, there will be many needs, but usable representation of a need is a requirement. So out of the many needs, you will get the requirements, right? Then usable representation of a requirement will become a solution. That means you need to find out how you're going to derive a solution out of these requirements, right? So then you are trying to team your forms. So there will be a project initiator, right? And you're going to have kind of a project manager. I'm telling project manager. So this is traditional project manager because now the things are changed. Things have been changed. So a project manager will be there. So he'll be forming the team. So you're going to have the development team separately. You're going to have kind of a QA team to get the quality aspect of your whatever coding that you do. Then you are going to have some UI UX team who is going to do the interface designing. And then UAT testing team, that is the front-end testing team, whether it's as per the requirement, as per the client acceptance, user acceptance testing has to happen. Then for the operation to go live part, you are going to have operations team. So as I mentioned, in order to make this particular solution a success one and to implement all the client environment, that means to go live, to make it to production, to make it enable for the end user access. So these whole teams has to work. But the problem is this traditional software development methodology, the team silo, that means, let's say, once the requirements are given by, let's say the business analyst is there, BA, right? Business analyst there, and he will get the requirements verified with the client and initial a prototype. There's a way the software is going to develop, the project manager is going to govern that one. So the development team, once the requirement is taken, the backlog, right? Backlog is the prioritized requirements, right? As per that requirement, so development team will start developing. So then development work. So what's going to happen? These teams will be taking, let's say, set of features of this particular software. Let's say the initial one is just to browse it, just to browse. Without the login, the client, customer want to browse what this e-commerce system. Now our example is online shopping cart, so it falls under e-commerce domain. So what are the items this particular organization, this particular business organization going to sell online? So they're going to browse it. After that one is login and authorization will come. So the first prototype may be just an interface, just a browser, right? And we set up a nice attractive pictures, images. Now, of course, we have the AI expert, so we will talk about that one later, how to generate AI and all those things going to do the AI on that part, but we'll come to that later. So initially, the interface will be there. So that will be the initial development part. So what dev team is going to do, they will take this as a release. So they have done the initial with the assistance of the UI UX team, the front end design is done, and they have the front end now, and the front end development is done. Now they are going to give release one. Release one. That means with the initial browsing page with the items that the organization is going to sell. Right? So release one. So what is the output here? Dev team, let's say after 2 weeks. So now the project manager is there. So he's the one who is going to govern this one. Let's say this is going to be agile style, right? Because we have the project management technique. So in agile style, we are going to have 2 weeks sprints, right? Sprints mean the release cycle. So now let's say the first output, that means the browsing part of this particular website, going to get released the first 2 weeks, first sprint. So then what's going to happen? Now this is a dev work, development now. So now this need to be tested. So then the QA team comes in. QA team is looking for, now let's say dev releasing means the code inspection and those things are there, like code review, code smell, those things are already done now. Let's assume those things are done, right? Then the QA team is going to come in. QA team is going to come in. Then QA team will be doing the quality. So likewise, what I want to explain here, so this is the traditional way of developing software. I have it nicely in a graphical. This is what I'm just explaining. This is what I was explaining, right? You can see without DevOps, you can see how the teams were working. So this is what I was explaining. Now you can see the business analyst getting the requirements, and you can see the business requirements are there. This is the development team, and the release is going to come. So this is where I was explaining after 2 weeks with the initial set of prototype, initial features, the browser, right? Then you are going to have a basic work in browser for the customer to browse the products. That's it. So the first 2 weeks, then the QA team is going to test this one, then the UAT team going to take the use acceptance, whether the client is going to approve this one. Then everything is okay, means operation teams, this team, ops team is going to put it to live, go live. That is in the production. Then client can access it. Sorry, the customer can access it. We can say client, right? But let's say client is the person who is on the organization. Customer, the end users, right? End users can access it. So this has been there in traditional software development life cycle, right? But you can see the team silos are very prominent here. It is very significant. That means the BA is major responsible, that he or she is worried about to get the clarity on the requirement, because it's very important to flow this requirement, right? Give this requirement for the developer, right? And they need to groom with the requirement, because if the developer is not having the clarity with the requirement, he's going to mess up with the development. That means at the end of the day, the product won't be as per the client requirement. So that's BA is very responsible for that, and the project manager also, they have to make sure that it is on time, delivery timeline is there. Right. Then you are going to have, see, this team, development team. So this is a different team, dev team. So this is team silo. That's why you can see the separations is there. Grooming, that is the developers are getting awareness of the backlog, that is as per the requirement, what needs to be done. The user stories, a lot of things going to take place here, right? Use case diagram to get the clarity, and the feature development, right? So feature by feature. So our first feature is to have a basic web page, probably the landing page of that organization, the home page of the organization, just to browse the products that is available to buy online. That's right. And then you are going to have the ops team. So you can see the team silo. BA and the project manager is there, dev team is there. Here I haven't given the QA team, and the operations team, UAT team. So these teams are isolatedly working here. So this the cycle. This is normal agile project management. So this had been there in the industry for a long time. And before this also, software development life cycle, traditional, and we had the waterfall method, then those things are there. But agile is much popular now. But now what happened with DevOps? This is DevOps. So DevOps break this culture, and they introduce, this is a new culture. If somebody asks what is DevOps, simple answer is it is a new culture of software development. It's a transformation from the traditional software development. Right? So this concept, introduce a new way of delivering software or the solutions as per the client requirement. That is what happens. Right? So with DevOps, you can see suddenly these barriers are taken off. This barrier is not there here. This barrier is not there here. That means that team silos are broken. We don't have any more individual team, no dev team, no ops team, no separate QA team. All are working together in a collaborative fashion to achieve the ultimate goal of what? delivering a high quality product as per the client requirement. That is the key objective here. Delivering a high quality product as per the client requirement. So we don't have separate teams, Dev, QA, no. Everybody works towards the same goal. That's what. So we don't have silos. That means QA, now here, QA team has to wait for the release. First 2 weeks, okay, release, Dev team has to give the new features as a kind of a release, then only QA team start testing. Here it's not like that. Right? So that is the major change here, but add on to that, we have terms like continuous integration, continuous development, continuous deployment. Let's see those things. So at a very high level, I just want to give this initial understanding for you all, just to get a basic awareness, and industry, in the industry, and what is the transformation which has happened in the industry. Hope you got a basic. Okay, let me continue in this way. We can look at the this topic statement is almost explained. So this is definition, but from Gartner. Because in the industry, we have many definitions for DevOps. So, okay, but Gartner is, I think hopefully everybody aware of Gartner. Gartner is the number one, we say for IT sector is the number one research publisher, right? So this is definition from Gartner. So what it says, DevOps is a customer value-driven approach to deliver solutions using agile methods, collaboration, and automation. So keywords are highlighted here. Customer value driven, very important, because at the end of the day, it is all about value creation. Value creation. When a requirement is given by a client, right? Here it says customer. That's true, because the value has to be gone for two sides, right? It is going to be win-win-win. Win-win-win, right? The organization, client, and the customer. So three parties are there. So here it says customer value driven. So the end users also have to realize the value, plus the client who is giving the requirement also has to realize the value. Because as per the requirement given by the client who has the need for a new software, new solution, new automated software, we need to make sure as a solution team, okay, let's say as a DevOps team, right, who is going to provide the automation, who is going to provide the solution, we need to make sure that we are adding the right value as per the requirement. That is first. It's all about value creation. We have to make sure, because from the requirement to cash, that is the concept here. Because this is a business. Why client is asking a solution for one? Because to increase their profit margin, because they are a business organization. So from the requirement to cash, cash means after selling their particular items online, they are going to earn more. They are going to get the competitive advantage over their rival. So that's the value we are going to create. Right. So approach to deliver, then agile methods. That's true. Now, DevOps doesn't going to stop. It's not going to stop agile. Agile is a project management technique that you know, right? So DevOps is going to shake hand with agile. So it's going to work collaboratively with the DevOps culture. Let's see how it's going to be, right? Because I think even in the previous pitch I mentioned, so agile, 2 weeks sprint cycles. So those things will make the governance of DevOps. We will see how it's going to work. We will see how it's going to work. So then collaboration and automation, I think we understood earlier, the teams are going to work collaboratively to do this automation, Now here, when you say automation, see, anyway, IT is going to automate the manual work. That's not the automation here we are talking about. Anyway, when now let's say if the organization is selling the products on-premise, they don't have a website, our example, online shopping cart. So they want to automate this one. That means they are going to enable IT to do the business in a faster way, rather than customer is going to visit to their site physically. This is their location physically and buy the product. They want to sell it online as well. So for that, we do some kind of automation by providing IT solution. But here, there's another automation they are talking about. Let's try to understand that, because that's automation comes from DevOps platform. Right? Because see, continuous integration, continuous delivery, continuous deployment. So when you say, I'm just telling this one briefly, but we need to understand in more detail. When you say continuous integration, the word itself, continuous integration. Now, earlier with the traditional development cycle, there was nothing called continuous. Let's say for that particular client to get the first feature, that means to get that landing page done, he has to wait at least, let's say, 2 sprints to be completed with the testing and everything. Probably after 1 month only, client is going to get the particular solution on live, go live. That's what's going to happen. So there's a particular time period. After 1 month, as per the project manager delivery timeline, the project manager, they will commit, okay, we are giving the first feature for you after 1 month. So there's a time period, committed time, 1 month of a period. But in DevOps, when you say continuous integration, that's not like that. It is not the way. There is always a deliverable product available in DevOps. That is what. This is known as continuous delivery. Continuous delivery. So continuous integration will make continuous delivery possible. That's why in DevOps we don't say project management. In DevOps we say product management. Product management. The reason is there is always something available for a customer to see, deliverable, always available. Always there is something deployable is available. That's what continuous integration. So let's try to understand those things. So similarly, we have continuous deployment as well. So that is how it's going. That's a part of automation. So we need to do CI/CD automation and the platform automation, because to have the CI/CD 100% successfully working, we need to have the infrastructure in place. So let's try to understand little by little. So this is just to tell that, I mean, this is possible in every currently in the industry. I mean, we have business sectors. Okay, let's say we have the communication sector there. We have the manufacturing sector there. So each business sector, we are going to have separate industries. Let's say in communication, we have telco industry. In manufacturing, we have apparel industry. So the business domain is nothing but the handshaking between the industry and the sector, right? So why I have put these particular images here? Now in almost most of these industries, if these clients want to get some automation done with IT, then they are looking currently a quick solution. Quick means time to deliver the particular software. They are expecting faster than earlier, due to the competition and the business nature. So therefore, every industry now DevOps, they are demanding kind of DevOps. That's why. So because DevOps is going to facilitate the requirement of all of these industries. That's why this image is there. All right, let's continue. Now this is clear. This is understood what I just explained earlier. Let's continue to the next one. So you can see now this particular line says DevOps culture. So DevOps collaboratively, operations team, development team, business analyst, everybody is going to work towards the same goal with a high quality delivery for the client. That is what. Okay. Let's continue. So these are definitions. I just use these few terms. We can see continuous integration, continuous deployment, continuous delivery. So these are the terms comes with DevOps. If an organization want to start with DevOps, so we have key requirements. They have to make sure this particular concepts, I would say continuous integration, continuous deployment, continuous delivery, is working at least 99% accuracy with the proper infrastructure. Because when you say continuous integration, you can see the practice of continuously merging code changes done by developers. That is continuous integration. It's like this. Now, normally in our agile traditional software development life cycle, the developer, he'll be working on a feature branch. That means there's a master branch, there's a feature branch. Because Now, our example was online shopping cart application. Now, to get this home page, that's the first prototype. Now, we need the landing page of the organization to be done with the list of products. Now, there are certain tasks to be done by each developer. So the project manager is going to make sure he's going to assign each development, keep the developer busy with assigned tasks with a proper estimate. Probably one developer is getting the interface design done, web page basic design. Probably another fellow is looking some nice adding images to the particular home page, and he probably working with some how the when the particular customer click on the image, what will be the next act, like that, right? The workflow, the process flow, like there are a lot user journeys. So there are a lot of requirements, lot of tasks, considerable amount of tasks to make sure this web page, landing page is up and running. So these tasks, the project manager is going to assign each developer. So each developer will be working on a basic set of codes. Let's say if this project is going to be delivered from Spring Boot, Java Spring Boot. Now in Spring Boot, developer one, this is now still is front end. There's nothing on back end because now we are talking about front end UI. That's all. Right? Web page is a requirement. But going forward, we are going to have the login is going to come in, adding to the cart is going to come in. Okay, deleting, checkout, payment, lot of things are going to come in as features. So these all are features, right? So now each developer will be responsible for these features, right? So in DevOps, continuous integration means as the developer checks in, we are telling check in. That means he has finished developing a certain feature. Then he's going to commit the particular code, his work, his task. He's going to commit it to where for the code repository. Code repositories. His software, his particular program will be saved in the code repository. Like probably GitHub or GitLab or whatever Microsoft Azure DevOps or whatever place the code repository is. It's going to check in there. Now in DevOps, what's going to happen? As it says, continuous integration. As the developer checks in the code, that means he confirms he has done that particular program for that particular feature. So then what's going to happen in DevOps, in the continuous integration phase, automatically this particular code will be checked for any quality. That means the QA work earlier, QA work was done manually, right? Now it's going to be automated. There are tools in the CI/CD platform like Selenium, SonarQube. So the code inspection, code quality check-in, everything will be automatically taking place in the pipeline, CI/CD pipeline. So I am telling now the first part, continuous integration is that as the developer checks in the code, saving or committing the code for the code repository, the desktop, the quality checking inspection will take place. And that is what is known as continuous integration. So in traditional cycle, this didn't happen because the quality check starts after 2 weeks. That's all. Okay. Then we have the other phase, continuous deployment. So once the integration finished, we have something called artifacts. We have the deployable artifacts. Artifacts is nothing much. Let's say earlier I mentioned something called master branch and a feature branch. Right? I can show you here. We have another explanation here. Let me show you the slide now. So I think it will add more clarity. So here we have this one. You can see master branch and the feature branch. You can see the master branch where all the features are going to delivered on this one. Ultimately, this is the one is we are going to be deployed. So what's going to happen? Each feature will get pulled into the master branch. So at the end of continuous integration, we are going to have a certain artifact. Artifact means what? What's going to get deployed to the production environment. Deploy means nothing much in a traditional environment. We know, I mean, let's say, to make sure that your understanding is very simply, you are going to Spring Boot application, you are going to run it. Let's say IntelliJ or whatever from the coding, you are going to run it on your normal computer. Let's say on-premise computer without DevOps or nothing, you are just going to develop. And once you run, what's going to happen? You're going to have a Java file. executable file, .jar file or WO file. So that is the file which is going to run your particular program. Okay, so that's in DevOps we are telling is a artifact, right? But artifact is a normal word, but is executable. So that jar file we are going to deploy. That is known as what? Continuous deployment. Continuous deployment. That's the second word. Continuous deployment. The practice of frequently deploying code changes to production. So continuous integration means what? Continuously merging the feature branch to the master branch. So once certain stage will be there, once the merge happens, there is something deployable, an artifact, a jar file or a file. If it is a containerized environment, we are going to have a container there, right? Container there. So that container is the one which is going to get deployed to the production environment. So that is known as continuous deployment. So as the integration happens, we are having we are always having something deployable. So continuous integration, continuous deploy. So, but we don't do this because as per the client need, there's an approval process. If the client okay to have the new feature set, then only we are going to be go live. That controls we can do, but in the DevOps, continuous integration, continuous deployment pipeline, that's the second one. The third one is delivery. The practice of continuously maintain the code in the deployable state. That's true. That is, these artifacts we are always putting in a staging server. We are keeping it in staging server as artifact, like we have the JProg and those places are there to store the artifacts. So we are going to keep the artifacts maintained, ready to be deployed. That is known as continuous delivery. So these are main three terms which is coming under DevOps, CI/CD. CI/CD means continuous integration, continuous delivery. And these stand for two things, deployment and delivery. So there is a theoretical understanding on this particular CI/CD word, and there's a practical understanding on this CI/CD word. So I was just trying to explain the theoretical aspect of this. The practical aspect is the infrastructure part. Infrastructure means how do you really make sure the tools, because to have the CI/CD, there's a pipeline. We need to have many tools available. So let's try to understand those things little by little. Right. Because now you may wonder, okay, now I was telling earlier, okay, as the developer checks in the code, okay, checks into where? I mentioned GitHub, GitLab, Azure DevOps. There are many code repositories, so that is one tool. Then the second tool, I told you again, continuous integration, you are going to store the artifacts. Where you are going to store the artifacts? Probably one of the repositories, another repository, that is artifact repository. I mentioned JProg. JProg is just one example. There are many others, right? So likewise, you can see now, to make sure that CI/CD theoretical background work into practically, we need to have set of tools. So let's try to understand what are those tools as well. Let's go further. So to the next one. So this is what the tools, you can see all about tools. So many tools, 1,000 tools are there. So this is the challenge in DevOps. Challenge in DevOps that currently organizations are facing to which tool to select in. That's the problem. So there are, I can show you. When I click, let me click this one, right? Now this is a periodic table of tools. If I click this, you will see it will launch digital AI, right? Digital AI. I hope the screen is clearly transiting because I switched to another screen. Digital AI, you can see kind of a periodic table is there. Periodic table. Now this periodic table is not the traditional that hydrogen helium one which is in science we learn. That is not the one. In this periodic table, we are having these all are tools. These all are tools. This is freely accessible for anyone, digital AI. Now these are what? Tools which is going to make sure that CI/CD pipeline is successfully working. Now we are having, you can see code repositories here, GitLab, GitHub, right? And we are having artifact, we are having deployment servers here, Kubernetes with containerization. We are having monitoring, right? Task top, right? We are having telemetrics. So here you can see now this each category. Now, for example, you can see for this one, release management. Now in this color, Jenkins is a build server because somebody has to make sure that this CI, continuous integration, particular all the things as the code checks in. Okay, who is going to detect? Okay, now developer checks the code, checks in the code. Who is going to find it out? There has to be a server that is known as the CI server, continuous integration server. So here, this release management or CI server like Jenkins, and it will make sure as the code checks in, he will keep on scanning. Okay, who is going to check in the code? Who is going to check in the code? It's going to trigger the pipeline. That means the continuous integration process will be governed by a CI server. Right? So we need to have those servers. And again, deployment. Once the integration is done, when the artifacts are ready in the staging server, and when the client approval is going to come in, client says, okay, we need the new feature. And as per our shopping cart application, probably they are telling, okay, now enable, add, delete, modify. Right? Okay, that's the next set of features. Okay, then that means we need to enable deployment. So who is going to govern our deployment? Kubernetes, because it's containerized environment. Likewise. Then to monitor the deployment is correctly done, we need telemetrics monitoring, right? So that is the telemetrics is what is happening properly, is working now. Now we are going to have a new set of features deployed, whether it's properly done, all the alerts and metrics. So we need to properly figure it out as the performance are okay, going well. So that's monitoring part. So we have Datadog and a lot of things are there in monitoring. So all tools are here, right? And at the moment, I think I can click, and if I click here, let's see, release management, it will go to that place. It should highlight, but seems the site is not giving that page at the moment. But this is each color, right? From this color, and let's say for another example, configuration automation. We have these things. AIOps is the artificial intelligence part, and continuous integration. So in this color. Continuous integration, if you look at the Git, and this is GitHub, these are, probably the CI, continuous integration tools, but seems like that color, you can take a look, have a look at it, right? Have a look at it. Now, these are GitHub is acting. Of course, now GitHub is not just a, GitLab is not just a code repository. It has the capability of acting as a integration server as well, right? So just have a look, and on the ground now, this is Azure DevOps, and you can see GitLab CI, Travis CI. These are integration servers. Circle CI, Maven, yeah, AWS, all tools to make sure that particular pipeline is a stable one. All are tools. Kubernetes, there's a deployment, right? And yes, Chef, this is infrastructure support, IAC tools. So let's have a look at those things later. Fine. So let me continue. Right now, this is one task tool mapping in the pipeline. Task tool mapping. Now, in DevOps, we are going to have these set of tasks just for understanding purpose. Now, in Agile also earlier I explained, we are going to have BA is going to get the requirements with the clarity, and dev teams after the grooming sessions, they are going to have the backlog. Then backlog will be prioritized. Backlog is nothing much of features demanded by a client as per the prioritization. Okay. So likewise, then the QA team, there's an order. So in DevOps also, you can see there's an order of precedence. First thing is plan. Okay. Then you say create, then verify. Okay. And release. Okay. This going in this circle: plan, create, release, deploy, telemetry is monitoring. So this configure is something else. Configure means overall infrastructure configuration. We try to understand that one little by little. Fine. So now this particular slide is going to give you the tools available for each step. For example, what are the planning? In planning, what we will do? Like this. Now, in this one, you can see the task is planned. So in planning, what we will do, normally in Agile project management, we have certain set of tasks initially before kicking off a project, right? So that means initially we have to make sure all the requirements are taken and the business case has to be done and a lot of things have to happen. So those tasks without any change has to happen in DevOps also, because we need to initiate the project. Without initiating, you can't kick off DevOps. Because when the requirements are with clarity only, pipeline will start. Right? So on the left-hand side, before kicking off the pipeline, there are certain set of tasks to be done. Of course, now we have tools which that also can be automated. That is possible. Taking the requirements also can be automated, right? It's there now. With AI, the things are changed, right? So let's see. And now tasks, that is planning. Then we have in planning, further we can divide that one into, you can see this is tools for planning, prototype defining. So these tools are available for in the DevOps environment for planning. You can see set of tools, and similarly, you are going to have again in the planning stage. So we are going to have two areas in planning. One is prototyping, defining the requirement. Second one is tools for planning the requirement. So initially we need to understand. So in traditionally, to get the more clarity on the requirements, we use the use case diagrams, a sequence diagram. So to get the visual form of a requirement rather than just writing the user story, to get more clarity on the user story. User story is nothing but just we are writing the requirement. Okay, so get more clarity on the user story. Before writing, to get more clarity, we can use use case diagrams. There are certain techniques that business analysts, of course, they have their own different techniques. But now, like that in DevOps also, for planning, we have certain tools. Right? So likewise, so these are tools. And then once the planning is done, then we need to have create, right? Create means the next step. We can see these are the steps in there. Software, likewise. And after that, we are going to have in create also, we have certain breakdown. Task create, when the very first thing is a code repository. What are the code repositories available? Because once the dev team is now in DevOps, once the requirements are defined and with clarity, then the next thing is what? Developers going to start coding that one. That they are going to start checking, they are going to start development. So we need the code repository here, and the build. Build is earlier the CI. I told you the Jenkins server, and here we have Circle CI. So this is continuous integration part. And very important thing is security aspect of it. Right? In DevOps, we have separate thing called DevSecOps. Right? I think we can touch upon that one a little bit later. So this is the security aspect, because we need to make sure that code vulnerability testing. Okay. And there are things like Vera code and software composition analysis, DAST and security and testing. So those things have to take place here and create. Then after that, the verification. Verification is mainly the quality testing and all. Right? So likewise, the tools are available here. These are the selected tools from the previous set of, earlier you saw that in digital.ai in the periodic table. So this is another way to represent the same thing as per the steps in the DevOps CI/CD pipeline. So these all steps are taking place in the continuous integration, continuous deployment pipeline. That's what's going to happen. So if you further take a look at it, we're going to have, so once the planning is done, then they know the requirement is this, then the development is going to start, then the verifying means code quality testing, code inspection is going to take place, like the SonarQube and Selenium and tools. Here we are talking about another set of tools, that's fine. And after that, we are going to get the release. So release will be that's the artifactory, and the tools, we can see the tools for that as well. And release management tools like Vagrant also there, Jira also is possible, JProc, earlier I mentioned the artifactory repository. And after release is done, we are going to get deploy. So deployment. So deployment tools, we can see very first thing is Kubernetes is there, and code deploy for like in we have in AWS code deploy. So TeamCity, Octopus, so a lot of Ansible is like infrastructure as code, but it's part of deployment as well. And you can see other tools also there. Then once the deployment is done, so it goes in order: planning, getting the requirements, start developing, quality testing, then the release, then through deployment, as I mentioned earlier in the pipeline, then monitor it. So to monitor, we have tools. You can see Splunk, TaskTop. There are a lot of tools available to monitor, make sure that deployment is a success one. Because now in production, once the deployment is done, it is in production. So we have to make sure there is no downtime. Deployment is as per the client requirement. Because if it is not, we have to call back the release. We have to revert it. Right? So we need to monitor it continuously. Then configuration is something like we have to continuously do. Configuration is happening right across this pipeline, because we need to make sure, like I mentioned earlier, this infrastructure is in place properly. So to make sure the infrastructure is in place properly, we have to configure. Initially, the very first thing is before kicking off DevOps, before starting this one, we need to make sure we have a very stable pipeline, CI/CD pipeline, continuous integration, continuous delivery, deployable pipeline. So to do that only, we have something called infrastructure, because infrastructure as a code is nothing much the automation of this tool integration. Okay, tool integration. You have to make sure that as the code checks in repository, then quality start. As the code checks in, inspection is start. Then the quality start. Then the artifact, then it's deployed, monitor. So there's a precedence, order of precedence. So who is going to monitor these things? That's why earlier to integration servers are there, deployment servers are there, monitoring also there. So likewise, and again, integration server is going to look after the code repository, quality, inspection, and the artifact. Then deployment is something. Then there's a deployment service going to look after the deployment, then the monitoring. So likewise, there's a whole lot of configuration has to take place right across this pipeline. So that is what I mean by configuration, left to right. Clear? Right. So let's go to the next one. Now this is CNCF, Cloud Native Computing Foundation. So again, this is another organization which is going to support, I mean, it's open source one, support business organization on this tooling. Tooling means now when there are a lot of tools, the challenge is there, which one to correct now. Right? And these people also are telling some recommendations, fine, okay, these are recommended for CI/CD pipeline, and these are just testing. Okay, these are mature products, graduated products likewise. So we can take a look at it. So if I click here, it will take you to the site. You can see cloud native interactive landscape. And here for us, the important part is this. We can see if you take to the right, continuous integration. Because here there are a lot of other tools as well, not only for DevOps, but you can see the databases. Most of the things are cloud, because nowadays definitely it's going to be cloud native development. There is very less the on-premise development is taking place, so it's cloud native. That means the development takes place in cloud. Right. So have a look at on this one as well. This is continuous integration. If I click that, it will take me to that. So for continuous integration, you can see the tools available. See Circle CI, even Jenkins is here. I told you CI is Jenkins is a continuous integration server. So we have Jenkins and we have Jenkins X as well. It's a GUI easily to configurable and no, but Jenkins, okay, we have the master and so it's very powerful. And we have Circle CI, we have SkyCap, so GitLab, and GitHub. Earlier GitHub only a code repository, but now they have extended to a CI server. So likewise, a lot of tools. These all are continuous integration. Example, Travis CI. Right? These are example for continuous integration servers. Get it? So just have a look at it, and a lot of tools. You can see the mess here. Okay, fine. So just have a look at it. That is CNCF, Cloud Native Interactive Landscape. Fine. Let's go to the next one. Right. Then it's all about value engineering. What do you mean by value engineering? It's like this. I told you earlier, value creation is very important, because more robust the platform is engineered. So now you know what is a platform is. CI/CD, continuous integration, continuous deployment. So that's the platform we are talking about. So theoretical aspect, practical aspect. So we need to make sure the flow is working very correctly. As the developer checks in, code inspection initiated, code quality testing initiated, artifacts are generated, artifacts are stored in the staging server. Then upon approval from the client, it is deployed. Deployment is done. If it is containerization, it's going to get containerized. Then image is going to get created, and container repository. We have the repositories to store the containers, right? And container registry has to be there. So those things are working. Then once it deployed, the monitoring is initiated. So likewise, the platform has to be very stable. So the more the stability, more the robust of the platform, more the value we can create to the client. That's what. Because this is the expectation. Because why we initiate DevOps culture to have faster quality, high deliver, high quality solutions delivered to the client. That is what. So we need to achieve that. To achieve, we have to make sure our platform is very stable. So these are just examples, and we know this now digitally. We saw this Azure DevOps also there in cloud. Not only Azure, we have Google. Right? All the giant cloud vendors, they have their own platforms, ready-made platforms. It is a choice between, are we going to have our own platforms or are we going to have ready-made platforms? We come to that. For an organization, they can decide upon, okay, we are going to build the CI/CD platform for our organization. Then it's up to them, their expertise. They need to have the in-house expertise to select the correct tool chain. What is the code repository? Okay, who is the CI server? What is the CI server? What is quality in which tools to make sure quality, deployable tools. So all the tools, that means they are making the decision of building their own customized robust CI/CD platform. The other choice is, okay, go ahead for ready-made platform. Think like Azure DevOps, AWS, code commit, code check-in, right? They have their own platforms. Google, they have. Oracle, they have their own platforms. And again, these are cloud platforms. Other than that, there are other giants also who are providing platforms, right? So it's up to the organization to decide. But nowadays, as per the research outcome, now most of the organizations are going for this ready-made platform because it's a huge challenge for them to make sure that customized tools, their integrated platforms are stable. It's a huge challenge, right? So let's see. Let's go to the next one. Now it is all about this. So this particular image is going to show you the flow of the pipeline. So this is the flow of the pipeline. Earlier we got the theoretical understanding of the CI, CD and deployment. Now this is the practical aspect. You can see the Git is the code check-in. Now this is a code repository. So as the feature branch pull request, so to once the developer check in the code, that the PR pull request will take place to merge it to the master branch. That then the code inspection before merging to the master branch, each feature branch code inspection has to take place. That means multiple pipelines will be working on the CI/CD platform, multiple pipelines. So because it's not only one developer, as far as only one or two developers are there, things are fine. But when the complexity increases, when the project becomes large, when many features are coming, product manager has to manage many feature branches, has to make sure delivery is up on the time. So then complexity starts. Then it's not going to be one or two pipelines. It's going to be in the same infrastructure. It's going to be many logical pipelines. That developer checks in, developer 1 checks in, developer 2 checks in, developer 3 checks in. So how are we going to manage this? Is we have to we make sure platform is very stable. So those are the complexities. This is small complexity I just mentioned, but there are many complexities. Other than that, in DevOps environment, if you are going to, if the organization in-house team going to bear the responsibility of governing the pipeline. Okay, so then code inspection, code quality. So SonarQube is example for code inspection. Selenium is another example for code quality. We know test case writing, test case automation. That's why the QA team, earlier they might be writing manual test cases, but now test case has to be automatically written, right? Now with AI, again, things have changed more. I'll come to that, right? Then artifact, I told you, after quality inspection, everything is done, we are going to have the artifact. That means build artifacts ready to be deployed, the jar file, the WAR file, exe file, or whatever, right, ready to be deployed. Image repository is nothing much if you are going for containerization. If it is Kubernetes, definitely we are going to get containerization because Kubernetes is a container orchestration platform, number one orchestration platform in the world at the moment. We have others also, but Kubernetes is leading. So definitely, if it is a microservice environment, if it is, our example I took is Spring, right? But there are other development platforms as well. So if it is microservices, definitely it's going to be containerized. And then you are going to have code image repository to track the images that we are building in the, to deploy in the container. Then we are going to have staging server. Staging is waiting to be deployed. So Kubernetes will take care of deployment, then the monitoring. So then task stop, these all are monitoring tools. Got it? This is how very basic, because pipeline based on the complexity of the pipeline, the stages may higher. But here we can't say very basic. This pipeline also an production ready pipeline, because whatever to have a basic delivery to the client, the steps are there, right? We have the containerized inspection, quality is fine. But in the production, there can be more steps, right? Complexity can go into high. Now, this is what value streaming delivery platform. And what is value stream delivery? Because earlier I told you continuous delivery has to bring in value to the client. And again, continuous deployment also has to bring value to the client. So we are going to have two things: value stream delivery, value stream management. So delivery has to be adding value, and we need to make sure we are managing the pipeline properly to have this one a success. And when you have both together, these are the tools, right? So we have ready-made delivery platforms in the world, Cloud B. Now JProg is not just Artifactory, Atlassian, and cloud management platforms are there, value stream management platform like you can see this is all about monitoring. So if both happen properly, then what you're going to have, the output is higher value added to the core value chain of the client business. So this is what. So we need to make sure our platform is stable, our monitoring is stable, so that our delivery will be much powerful and as per the client requirement. Hope is clear. So let's go to the next one. Then the other one, the latest is AI augmented DevOps. AI augmented. So AI has now, we know artificial intelligence is nothing new. It has been there in the industry for many years, right? But now the latest addition is generative AI, GI, right? Generative GAI, generative AI. That's where all of these ChatGPT, GPT, and Bart Chat, Microsoft Copilot, and everything is in place. Okay. But generative AI also, the theoretically it has been there in the industry for last 7 to 8 years, but now it is become one of the main streams in the industry. Because currently in the industry we have three main streams. One is the analytics, and another one is the cybersecurity, third one is AI. Right? So AI is everywhere. So why not DevOps? So for DevOps also, AI augmented DevOps is there. AI augmented DevOps means now earlier we talk about the traditional software development life cycle. Now we talk about a DevOps automation. Now we are talking about AI augmented. So further optimize. That is what. So how is going to happen? AI augmented software development. Now, as per the predictions, your codes, the developer codes in the future, 60% will be written by AI tools. We have many examples, right? And you can see almost the examples are here. This Bing Chat, Git, you can see, and OpenAI, Codex, Synapse. So these are tools. And further, software testing will be further automated with AI. These are the tools currently available. These are few. There are many tools, and even for design, AI augmented UI UX design. Earlier I told you landing page design. There are many tools available with AI, and this is monitoring, AI Ops. This is for monitoring. Earlier we talk about descriptive diagnostic. With the normal way, you had to monitor. Yeah, you get the description, you get the log files and trace file with LT stack and everything, and you have to diagnose the root cause, RCA. You have to find the root cause. Right? Now it's becoming predictive, prescriptive. So now AI tools are going to predict it. After that, we can just prescribe, okay, this is the treatment. So that's a new way, right? Predictive and prescriptive analytics. So we have things, tools like Science Logic, Splunk. So these are AI ops. So in the pipeline, these things, CI/CD pipeline in DevOps, these things are also playing a massive role, and it's going to further optimize the pipeline with the higher accuracy and higher quality. All right. Fine. So this is a prediction again from Gartner. By 2027, 70% of the professional developers will use AI-powered coding. What is going to happen? Up from 10% today, up less than 10%. So that's a 70% of the professionals. Okay, 70%. You can see how it's going to 2027. So how it's going to change the coding, world of coding. So it's no longer bulk codes totally written by developers. Okay. Right, so then DevSecOps. So I think I mentioned this one as well earlier. So this is the security aspect of DevOps, DevSecOps. So definitely everywhere you're going to have security. And so what's going to happen for our pipeline, static analysis and code reviews, and we have the software composition analysis, and AI. So this goes with cybersecurity as well. So this is the security aspect of DevSecOps. Right? You can see integration security into Dev practices, weakest link of the chain, always the human factor. So that's why, because in DevOps, human involvement is less because things are automated. But there are different jobs for human, not the traditional job, right? We know DevOps engineer, infrastructure manager, product manager, a lot of other jobs are emerged in a different way. So that's what's going to happen, because we are not going to lose the jobs. Even in generative AI, what it has done is a technological disruption. Technological disruption. So whenever a disruption comes into the industry, a new emergence of jobs will come in a different way. So it's up to us to adapt that new trend. So we are not going to lose it, but the old set of roles will go sunset. It will go down slowly. New set of job roles will come up, like prompt engineering for AI. Okay, fine. So this is again DevSecOps security. So I'm not going to touch security part here mainly, because it's going to drag this session further. But just to give an idea, only the security aspect also there. And the right start. So if some organization is going to start with DevOps, so this is the way it should go on. You can see right start for DevOps. So first step, if an organization is looking to start with DevOps, the very first step is they need to figure out, is there any real business need? Because this is not just something to play with. The decisions has to be very firm. So step one is, do we really need to go for DevOps? Are we ready? Are we ready? Now use cases like Netflix. Netflix is one of the best use cases for DevOps. They adapted DevOps. Now you know what has happened to Netflix. I mean, profit margins, everything, right? And number of subscribers, right? And their tracking systems. Very powerful, because DevOps changed their business actually. They got very revenue-wise, CAGR went very high because of their that particular cultural shift, DevOps. Right? So we didn't figure out whether DevOps is the right fit. Most of the case, this answer is yes, but then we have to make sure what does DevOps means. We need to define DevOps as per our organization. Then cross-functional teams. Yes, I told you it's a cultural shift. So now currently probably the traditional way of thinking. Okay, we have the dev team. We have the dev team is always trying to push the new release, because that is their job. Because developers will have work, only the new features are going to come. If the backlog is keep on coming on, a developer is going to have the work, right? Otherwise, they'll be idling. So that means they have to make sure always the release is going. And QA team is waiting for testing. Now this is the traditional method. No? Now how we are going to shift this mindset to DevOps? So DevOps is going to change the things. So we need to make sure the cross-functional team, that particular paradigm shift, the mindset change, the new culture is established within the organization. That's the number one thing, right? So I think then if you listen to the again Netflix CEO, he has explained in the YouTube, we have a nice video of how they did the cultural shift, and then establish the right culture with the paradigm shift. This is the same thing I explained. Then step 5, define shared objectives. Of course, earlier there were unique objectives for developer. There were unique set of objectives for QA. Now it is going to be shared, because collaboratively all the teams are going to work together to achieve the high quality deliverable product at the end. That's what. And again, the step 6, identify the starter apps. So which one going to start? Where to start with DevOps? Which organization? Which requirement? That's what. If you are an IT organization, if you are a solution provider, if you have existing set of clients, okay, this client, that client, which is the priority? Which application we are going to take? This client also asking this new feature. Are we going to do this with DevOps? That's what. Okay. Because see, kickoff, first impression is very important. Focus, eliminating the silos. We know that silos means team isolation, QA team, ops team. There are no teams separately. All works in one unique goal. Okay. Then robust platform. That's the very important thing. Finally, before kicking off DevOps, we need to make sure our platform is very stable. Okay, so this is just set of steps for an organization to make sure DevOps is a success. Fine. So this is finally the market. Currently in the industry, the demand for DevOps, you can see 2023 to 29, the prediction, continuous capital growth rate, right? Component. This is just assets, right? Growth rate, CAGR. Okay, so and this, you can see continuous is a growth, and this is across the globe, North America, Europe, Asia Pacific, how the DevOps has been picked up type of segments, and this is across the industries and all. And you can see the key players in DevOps. You can see Oracle, IBM, Amazon, even Azure. So these are the HP, Google. We can see key players in DevOps. Right? This is from MMR, so that is a market research. So that is what. Yeah, so this is the way the industry is currently supporting DevOps. So there's a very big demand, and we have the services and the solutions. Two segments are there because, of course, that's the way it's been offered. Yes, so that's fine. And yeah, so with that, I think we are almost is coming to the end of this explanation on DevOps, the traditional and the transformation, and how the platform has to be well engineered. Fine, I think we can open for QA. Yes, okay, thanks for listening. I think over to you, Prabhani. I think we can open for QA. Yes.
Yeah. So thank you very much, Mr. Luxury, for those insights. So with that, now it's chance for our audience to raise their questions. So you could either unmute yourself or leave the question in the chat box. Yeah, you can post the, if you have any question, you can post the questions in the chat box. Yeah. So for today, this event, actually the many young professionals and undergraduates have joined. So to offer some advice, what do you believe? What are the requirements? What are the kind of requirements uh, becoming DevOps engineer, and what specific skills need to be developed to pursue a career in this field?
Okay, sure. Yeah, let me answer that, take that question, Dr. Prabhani. But to that, I think I have a small slide as well. Let me show you the DevOps career ladder. Yeah, let me share this screen for a while. I think this will give the proper idea for that. Yeah, I got that slide. Yes, let me share the screen. Yes. Okay, I think screen is clear.
Yeah, it's visible.
Yeah, so this is if someone want to become a DevOps professional, let's say the role is expected role is DevOps engineer. So we have something called an industry role ladder. So this ladder is nothing much, just a step by step process. If somebody want to pursue a DevOps career, so very first thing, let's say the fellow is a very first starter. I mean, as an intellectual resource, he doesn't know anything. So now the latest is rather than going for searching Google. Right, we know Google is a search engine, but now we have reasoning engines, ChatGPT and Bart Chat and Microsoft Copilot, and yeah, those are popular, right? So ask from ChatGPT first, right? ChatGPT first. Okay, I want to become a DevOps engineer, right? And then you can continue the ladder like this, and you can see what is DevOps, and you need to find out now almost you know what is DevOps. Now I think certain knowledge from this session almost given. So it's just a matter of enhancing your knowledge on these steps. What is CI/CD pipeline and how this can be practically implemented. Of course, in my learning platform, I can share this one later. So it is explained very basically, practically how to build a very basic pipeline with Jenkins, and as the code checks in, how the deployment happens. So we have to start with Docker and containerization. So then we can continue further. What it is HashiCorp, Terraform, Cloud Formation. I didn't use this much of technical words in the presentation, but see infrastructure as code automation tools, Ansible, Chef, Puppet. So those you have to learn those things just to find out what is. Then containerization, Kubernetes, basic idea, because if you are going for DevOps, definitely containerization is going to be part of it. Then ready-made pipelines, I just mentioned these things, AWS, and there are other ready-made pipelines, then the monitoring things. So basically, if anyone want to take DevOps as a career, so this is a ladder. Across this ladder, you can have awareness first awareness of everything, then select as of your choice. Now, for example, DevOps can become a total unique career for you, right? Kubernetes. Kubernetes can become a unique career, right? Because in Kubernetes itself, there are a lot of things to learn, right? And monitoring can be a separate term. So in this ladder, there are separate hidden roles, right? But overall, yes, as a DevOps engineer, you need to have awareness. Hope I answered your question, Prabhani.
Yeah, thank you very much for your insightful clarification. There's one more question in the chat box from Michelle. If someone from another field move to this DevOps, where should he or she start?
Yes, exactly. That is known as this is reskilling. That comes because normally in the industry we expect all the resources to continuously. This is like the CI/CD pipeline, right? Okay, so resources has to also be in CI/CD manner, right? Continuous upskilling, cross-skilling, reskilling. So another PL means he doesn't have idea about DevOps, but yet he want to reskill to DevOps, right? So ultimately, he become a versatile resource. Versatile means anytime he need to adapt the new technologies. Okay, same ladder can be used. Same thing, right? So start learning about basics about what is a CI/CD pipeline. So that's the very first thing that resource should look for, because currently he may be a developer. He knows about Java, .NET. He might even a Python developer. Probably, generative AI. Okay, find out what is the CI/CD pipeline, right? How it works. Then try to implement basic CI/CD pipeline. I think Jenkins is a very basic tool to start with, right? And you can use the standalone cluster of Kubernetes, right? We have now Kubernetes is a little bit advanced now for someone to touch upon because it's a production level cluster. But you can have Minikube standalone cluster, then deploy in your environment, probably in your laptop, right? No need to go for even cloud. So start very basically like that. Then you can have a nice career way forward, because there was very demand, right? If you switch to the track, definitely you are going to be highly paid in the industry. Yes.
Yeah, thank you very much for the informative response. Actually, I have another one question from the security side. So actually, what are the security mechanisms that Jenkins uses to authenticate the users?
Jenkins.
Yeah.
So Jenkins actually, we can say in a very basic implementation, because Jenkins is one of the popular one in the industry. It can go for standalone server and master slave configurations. So if you look at the basic level, Jenkins, let's say there's only one Jenkins server. That is going to be the master server. There are no slave servers. Because as I mentioned earlier, when the number of developers increase, it has to bear the workload. No? Then Jenkins, we have a configuration called master slave configurations. When the number of pipelines increase, we are pushing them into the slave to offload the workload from the master server. Let's say if you don't have that much of complexity at the basic level, Yeah, I think you're asking about the authentication because normally in the DevOps environment, we have authentication, authorization are two different things. Authentication nothing but just login in, just login in. Authorization is we are positioning him, which role he is going to play. So answer for authentication, we have, let's say, basic password authentication is there. But nowadays it is not secure. So Jenkins supports advanced authentications like certificate-based authentication. So we have something called certificate authority. And I think you all aware this Active Directory-based authentication Microsoft uses. So we have advanced authentication like CA-based certificate authority, token-based authentication, and we have Active Directory-based authentication as well, because we can integrate Windows Active Directory and Linux LDAP with Jenkins. That is possible. So advanced. Yes. Okay. I hope it's clear.
Yeah, thank you for your expertise. Actually, any other questions from the audience? Seems no questions from the audience. The one last questions, then yeah, running out of time also. So the one last question. So why has the DevOps gained prominence over, or what do you think it's gained prominence over last few years?
Exactly. That's a good question. So because the demand in the industry now, as I mentioned earlier, the organizations always look for the quality of the deliverable. If we bring in a solution for an organization, the quality matters because zero defects, we cannot tolerate defects. So more the human involvement in the process of development, higher the error. That is very clear. Now DevOps is automating. So less human involvement, human are involved in a different way, monitor, configure, but the really deliverable is in the pipeline. That is what CI/CD is. So then we are going to have a error-free, very highly quality product. That is one reason. There's another reason I can tell you. The time to market, or I can say time to deliver the product is less. Now in agile project management, we had to wait for 2 weeks, 1 month to get the first thing into the go live, right? But in DevOps, continuous integration, continuous deployment, always, anytime, once the client approves, it is ready to be deployed. Right? So they have the feature ready available in a faster way. So these are, I think, very few reasons. There are many others, but security aspect. So now the AI is coming in, so it's going to be more demand. I think the traditional thing is going to go away little by little. Yes.
Yeah, thank you very much for the insight clarification. Uh, so I think it seems like no more questions from the audience. So then with that, we come to the end of the questionnaire and answering session. And so I would like to take this opportunity to extend my heartfelt appreciation to our resource person, Mr. Laksuri Balasuriya, for sharing valuable insight and expertise with us today. So we are truly grateful for your contribution. And also, I would like to thank all the volunteers who helped to make this event successful, including the support given from IEEE Student Activity Chair Michelle and WIE Chair and IEEE Computer Society. For our wonderful audience, thank you for your participation. And we hope that you found this discussion is informative and inspiring. So thank you, everyone, and have a pleasant evening.
Oh, sir, come, okay. Have a great evening, right?
There.
Okay, bye.